All right, this is just a quick introduction to the Cezanne app. What we have here is a core scan taken with the Tracer 5i engineering unit using an experimental setup. The data was collected for about 15 seconds, so each little dot you see in this map was taken for 15 seconds. And then we applied a calibration to it using the CloudCal app. So in this case, we just integrated that code into this app. Now, one of the big challenges I ran into is that RTAX unfortunately does not save the time of acquisition, which makes it more difficult to apply a calibration since obviously variance occurs. So here I've added a rhodium scaler where you can basically scale to either the rhodium L or K line, depending on the type of spectra you've taken. And then you also have an additional scale factor, so you can judge based on the quantities presented here. Ideally, if there is ever any integration with RTAX, that would be something to be addressed, but for the now being, we've got to work with what we've got. So in any case, we are using about 30,971 separate spectrum, taken at 15 seconds each. Once again, the product of Bayesian deconvolution, and we're using a calibration. Now, the benefit of that is for this map, which is for aluminum, if I float my mouse over a given point, I can see the chemical chemical concentrations for that element at that point. So about 2% aluminum over here. If we go to the bright red bands up here, we get from anywhere from 3 to 4%, or even 5% aluminum up here. The white here are dropped values where the aluminum was low, and that is something the user controls because they can control this threshold here. So this is set to reject 10% of the photons. This is just used to help make things a little clear. And then there's a number of different color ramps. So for example, if I chose rainbow and we plotted that, we would have a different color frame, as you can see here. I could also use a traditional heat map. In any case, the user has control over how they want to display their data. The other thing is you can, of course, change to different elements and different lines produced by the RTAX data, though uninformed users should know how to use it. And then you can also change the interpolation. You can download a table of the data. So in other words, this will produce the quantitative results. And then you can download a TIFF, which is already formatted for publication in either scientific journals or books, and a JPEG if you just want to share on the internet or Facebook. If we come over here to 3-element map, you will see a 3-element overlay. So in this case, we do traditional false color imaging. So we assign a color channel to each element, and then we overlay them, and then this is the result. If I float my mouse over, I see that at this point, I've got more aluminum, or actually I've got about 1.2% aluminum, 1.8% calcium, and no iron. I've got these red specks here, and if I float over, I can see that there is about 1% iron in those. What's nice about this is the color overlay for geologic materials actually does a great job of implicitly showing you the chemical concentrations within the data you're looking at. And of course, you can change the elements, change the color. You can also zoom in. So if I want to zoom in to see these inclusions, I would take and draw a box here and then click plot, and that will zoom in to that portion of the map. So I can get a closer look. Let's try that again. So we can zoom in. Oh, sorry. So one thing you have to do is you have to double click. That sets the zoom. Then I click plot. Then it zooms in. But in any case, here you can see a lot more detailed of an image here. So if you really want to explore the data in here, you can. And of course, the limit depends on how you take the data. If you want to zoom out, double click here and then click plot. We use plot to isolate out each action. Otherwise, the app becomes very intensive. Here, I can change the colors. So if I wanted to skew this to, let's say, a pink, purple for aluminum, I can do that, and we'll plot that. Let's do that one more time. Shift there. So you can't plot the L line, but when we return to the K line, you will see the color changes sometimes take a little while because the rastering is a little different, but then we get a color change. And this just helps make a little more aesthetically pleasing maps. And of course, to the eye, you can see that there's much more aluminum up here. We also have a 5-element map system. So same thing, but you just add 5 elements. We haven't quite found the ideal, but we're still getting there. The other thing is that this app automatically proportions the scale on the X and Y axis so that everything is equal. But in any case, that is just a brief introduction to the app. Let's take a quick look at 5 elements, actually. So you'll get an error result if you get an unusual line. So this being a light element spectrum, we do not have the barium K line, obviously. So let's try this map, see how it looks. Now, data processing for this app takes quite some time because of the large data sets being used. We're exploring using multi-coring and different computer setups to see the most optimal way, but provided the user is patient, they will get very high quality maps from this as well. As before, you can set threshold for each individual element. And so if you want to emphasize or de-emphasize different elements. So for example, if you only want to show where, potassium is at its 90% highest concentration, that's when you would really adjust the threshold indicators. As before, you can change the colors that are present as well. And then as before, you can download a high resolution TIFF. So in any case, that's just a brief introduction to the Cezanne app. It also can do semi-quantitative. So if I were to come over here and uncheck use cal file, this would open up all elements in the artax file. Right now, it only filters for those that currently have quantitative data. But in any case, we'll just toggle that. And when I come over here, you'll see that I have new elements that I can look at. So for example, if I wanted to see chlorine, and let's use the traditional terrain map. Now, this isn't an element we have a calibration for. I can still get semi-quantitative data for that element. So when you upload your data, you can toggle back and forth between a quantitative mode using calibration apps from CloudCal, or you can toggle to a semi-quant mode, which gives you the traditional mapping that you're used to with other software. So in any case, that's just a brief introduction. Thank you very much, and let me know if you have any questions.